Welcome to our channel. Today we're diving into the icy depths of one of Jupiter's most intriguing moons, Europa. Here are 10 fascinating facts about this mysterious world. This celestial body, nestled in the gravitational embrace of the gas giant Jupiter, beckons us with whispers of a hidden subsurface ocean, a potential cradle for life beyond Earth. It's a place where cosmic radiation battles a tenuous atmosphere and where the very surface hints at dynamic processes churning below. Prepare to have your cosmic perspective expanded as we journey to this distant, frozen frontier. Europa isn't just another rock in space, it's a prime candidate in our relentless search for habitable environments within our own solar system. Its story is one of ice and water, of tidal forces and geological youth, and perhaps, just perhaps, of biology. As we peel back the layers of this Jovian moon, we're not just exploring a celestial object, we're probing the very conditions that could give rise to life, challenging our understanding of where and how life can exist. The universe is vast, and Europa represents one of its most compelling mysteries. A tantalizing prospect that keeps astronomers and astrobiologists gazing skyward with fervent anticipation. So, buckle up your cosmic seatbelts. We're about to embark on an intellectual expedition, exploring 10 mind-bending truths about Europa that highlight its unique place in the solar system. From its historical discovery to the cutting-edge missions designed to unlock its secrets, each fact will illuminate why this moon captivates the human imagination and fuels our quest for knowledge. Get ready to see Europa not just as a point of light, but as a world of profound scientific interest and boundless possibility. Our journey begins, as many cosmic tales do, with a glance through a telescope. It was the year 1610, a pivotal moment in the history of science. The renowned Italian astronomer Galileo Galilei, peering through his newly improved instrument, turned his attention to the heavens and in doing so forever changed our perception of the cosmos. Among his groundbreaking observations were 4 points of light dancing around Jupiter. These weren't mere stars, as initially thought, but moon celestial bodies orbiting another planet. Europa was one of these, a member of what we now call the Galilean moons, alongside Io, Ganymede and Callisto. This discovery was revolutionary, providing compelling evidence for Copernicus's heliocentric model, a universe where Earth was not the center of all motion. Think about the profound shift in understanding this represented. For millennia, humanity had looked up and seen a relatively static, Earth-centered sky. Suddenly, with Galileo's observations, the universe expanded, became more complex, more dynamic. These 4 moons, including Europa, were a direct challenge to the established geocentric worldview. They demonstrated that other planets could have their own satellites just as Earth did. This wasn't just an astronomical finding, it was a philosophical one, pushing humanity towards a new era of scientific inquiry and a deeper appreciation for the intricate mechanics of our solar system. Europa's story, therefore, starts with this monumental act of looking up and daring to question. Now, let's delve into what makes Europa truly extraordinary. It's widely recognized as an ocean moon. This isn't just a poetic descriptor, it's based on compelling scientific evidence gathered over decades of observation by spacecraft like Voyager and Galileo. Beneath its thick, fractured crust of water ice, estimated to be several kilometers, perhaps even tens of kilometers deep, lies a vast global ocean of liquid salt water. Imagine an ocean possibly containing more water than all of Earth's oceans combined, sloshing around this distant moon, hidden from direct view by a formidable icy shell. The presence of this subsurface ocean is one of the most exciting discoveries in planetary science. The evidence for this ocean comes from various sources. Magnetometer readings from the Galileo spacecraft detected an induced magnetic field within Europa, which is best explained by the presence of a conductive layer beneath the surface. A salty ocean fits this description perfectly. Furthermore, the geological features on Europa's surface, such as the chaotic terrains and lineae, strongly suggest interactions between a liquid interior and the icy crust. This hidden sea is not just a passive body of water, it's a dynamic environment, potentially warmed by tidal forces from Jupiter, making it a focal point in our search for extraterrestrial life. It's a cosmic secret waiting to be fully unveiled. The existence of a colossal liquid water ocean naturally leads to one of the most profound questions we can ask. Could Europa harbor life? This moon is considered one of the most promising candidates in our solar system for finding extant extraterrestrial life, and for good reason. We know that on Earth, wherever we find liquid water, we generally find life, even in the most extreme environments. So the first key ingredient, liquid water, is almost certainly present on Europa in abundance. But water alone isn't enough. Life, as we understand it, also requires a source of energy and the right chemical building blocks. Scientists theorize that Europa might possess these crucial elements as well. Tidal flexing caused by Jupiter's immense gravity and the gravitational pull of the other Galilean moons could provide the necessary energy to keep the ocean liquid and potentially drive hydrothermal vents on Europa's ocean floor. These vents, similar to those found in Earth's deep oceans, could supply chemical nutrients and energy, creating oases for life. If such vents exist, they could be chemosynthetic ecosystems, where life thrives on chemical reactions rather than sunlight. The prospect of a lightless biosphere, teeming with unique organisms, makes Europa an irresistible target for astrobiological exploration. When we gaze upon Europa, even from afar, one of its most striking features is its brightness. This isn't just an aesthetic quality, it tells us something fundamental about its composition. Europa's surface is predominantly made of water ice, and this icy shell is incredibly reflective. In astronomical terms, it has a high albedo, meaning it reflects a significant amount of the sunlight that strikes it. This makes Europa one of the brightest objects in our solar system, a gleaming jewel orbiting Jupiter. This pristine icy veneer is not just a static, unchanging landscape. It's a dynamic interface between the harsh environment of space and the potentially life-sustaining ocean below. The icy surface isn't perfectly smooth, however. It's crisscrossed by a complex network of dark streaks and ridges called lineae, and mottled with areas of disrupted ice known as chaos terrain. These features are geological clues hinting at the processes occurring beneath. They suggest that the ice shell is not a rigid, impenetrable barrier, but is subject to stresses, fractures, and perhaps even upwelling of warmer material from the ocean below. The water-rich nature of the surface, constantly being renewed and reshaped, underscores the moon's active geology and its intimate connection to the vast ocean it conceals. This interplay between surface ice and subsurface water is key to understanding Europa's potential habitability. Much like our own moon, which faithfully presents only one side to Earth, Europa is tidally locked with its parent planet Jupiter. This means that Europa completes one rotation on its axis in the exact same amount of time it takes to orbit Jupiter. As a result, one hemisphere of Europa perpetually faces the gas giant, while the other hemisphere forever looks away into the depths of space. This phenomenon isn't a cosmic coincidence. It's a common outcome of gravitational interactions between a large celestial body and its smaller satellite over eons. The immense gravitational pull of Jupiter has effectively braked Europa's rotation until it reached this synchronized state. This tidal locking has profound implications for Europa. The constant gravitational tug-of-war isn't uniform across the moon. Jupiter's gravity pulls more strongly on the near side than the far side. This differential pull creates immense tidal forces that stretch and squeeze Europa, a process known as tidal flexing. This flexing is believed to be the primary source of internal heat that keeps Europa's subsurface ocean liquid, despite its frigid distance from the sun. So, while one side always gazes at the magnificent swirling clouds of Jupiter, the entire moon experiences the relentless gravitational dance that makes it such a geologically active and astrobiologically interesting world. Europa's journey around Jupiter is a remarkably consistent one. Its orbit is nearly circular, not highly elliptical like some other celestial bodies. This near circularity, combined with its orbital resonance with Io and Ganymede, meaning their orbital periods are in a simple numerical ratio, plays a crucial role in maintaining the tidal flexing we just discussed. If Europa's orbit were perfectly circular and it wasn't influenced by its neighboring moons, the tidal bulge raised by Jupiter would be static, and there would be little to no internal heating from flexing. However, the slight eccentricity of its orbit, maintained by the gravitational nudges from Io and Ganymede, means the intensity and direction of Jupiter's tidal pull constantly change as Europa moves. This rhythmic variation in gravitational stress is key. As Europa orbits, it's continuously kneaded like dough, causing friction and generating heat within its interior. This internal heat is vital. It's the engine that likely prevents the subsurface ocean from freezing solid and could power geological activity, such as the aforementioned potential hydrothermal vents. So the subtle dance of orbital mechanics, the near-circular path, and the gravitational interplay with its sibling moons are not just celestial curiosities. They are fundamental to Europa's status as an ocean world and its potential for habitability. It's a delicate cosmic balance that creates a surprisingly dynamic environment. One of the most compelling pieces of evidence for Europa's subsurface ocean comes from a rather subtle cosmic clue: its magnetic field. Europa itself doesn't generate its own intrinsic magnetic field in the way Earth does through a dynamo in its core. Instead, it possesses an induced magnetic field. This fascinating phenomenon occurs because Europa orbits within Jupiter's immensely powerful magnetosphere. As Jupiter rotates, its magnetic field sweeps past Europa, and if Europa contains a layer of electrically conductive material, this changing magnetic field will induce electrical currents within that layer, which in turn generate their own magnetic field. The Galileo spacecraft, during its multiple flybys, detected precisely this kind of induced magnetic field at Europa. The strength and orientation of this field strongly suggest that the conductive layer is a global ocean of salty water, located relatively close to the surface. Salt water, being a good conductor of electricity, fits the observations perfectly. This finding was a game changer, transforming the idea of a subsurface ocean from a strong possibility to a near certainty. It's a beautiful example of how we can probe the hidden interiors of distant worlds, using the fundamental laws of physics, listening to the magnetic whispers that betray the presence of a vast, concealed sea. A constantly renewed canvas, Europa's youthful complexion. When we look at many celestial bodies in our solar system, like our Moon or Mercury, their surfaces are pockmarked with countless craters, scars from eons of bombardment by asteroids and comets. These craters serve as a historical record, telling us about the age of the surface. However, when we turn our gaze to Europa, we find something strikingly different. Very few large impact craters. This scarcity of large craters doesn't mean Europa has miraculously avoided cosmic collisions. Rather, it strongly indicates that its surface is geologically young and dynamic. Some estimates suggest the surface might be only a few tens of millions of years old, a mere blink in cosmic time. This youthful complexion implies that active geological processes are constantly at work, erasing or covering up older craters. Think of it like a planetary Zamboni smoothing over the ice. These processes could include the upwelling of warmer ice from below, cryovolcanic activity where water or slush erupts onto the surface, or tectonic-like movements of the ice shell. This constant resurfacing is intrinsically linked to the subsurface ocean. The ocean provides a mobile layer beneath the ice, allowing for movement and renewal, and potentially providing the material for these resurfacing events. Europa's smooth, relatively unblemished face is a testament to its ongoing geological vitality. Chapter 9. The Great Ice Rink, Europa's Remarkably Smooth Terrain. Beyond the scarcity of large craters, Europa's surface, on a large scale, is remarkably smooth. While it's not perfectly flat, it has those fascinating lineae and chaos terrains. It lacks the towering mountains and deep valleys that characterize many other rocky or icy worlds. If you could stand on Europa, which would be quite a feat given the radiation and cold, the overall impression over vast distances would be one of relative flatness, like an enormous cosmic ice rink. This smoothness is another significant clue about the presence and influence of its subsurface ocean. The prevailing theory is that the liquid ocean beneath the ice shell decouples the crust from the rocky interior, allowing the ice to adjust and settle more uniformly. Imagine a thick layer of ice floating on water. It's going to find a more level equilibrium than if it were rigidly attached to an uneven rocky base. Furthermore, the movement of this ice, perhaps in large plates similar to Earth's tectonic plates but made of ice, could contribute to smoothing out irregularities over geological timescales. The chaos terrains, jumbled blocks of ice that look like broken and refrozen icebergs, are thought to be areas where the ocean has melted through or significantly thinned the ice shell, causing collapse and subsequent refreezing, further shaping this uniquely smooth yet dynamic landscape. The next chapter, charting Europa's secrets with Clipper. Our understanding of Europa, while substantial, is still based on tantalizing glimpses and clever deductions. To truly unlock its secrets and assess its habitability, we need to get a closer, more detailed look, and that's precisely the goal of NASA's Europa Clipper mission. Launched in October 2024, this dedicated spacecraft is embarking on a multi-year journey to Jupiter with the primary objective of performing dozens of close flybys of Europa. It's not an orbiter of Europa itself due to the intense radiation environment, but it will make repeated, targeted passes, gathering unprecedented data. Europa Clipper is equipped with a sophisticated suite of scientific instruments designed to investigate virtually every aspect of this enigmatic moon. These instruments will map the surface in high resolution, determine the thickness of the ice shell, measure the depth and salinity of the ocean, search for plumes of water vapor erupting from the surface, and characterize its composition. The overarching goal is to understand Europa as a system, its ice shell, its ocean, its composition, its geology, and ultimately to evaluate its potential to harbor life. This mission represents humanity's next great step in exploring ocean worlds, and could fundamentally change our understanding of life's potential in the cosmos. Europa's enduring allure and our cosmic quest. And there you have it. 10 mind-blowing facts about Europa, Jupiter's captivating ocean moon. From Galileo's initial discovery to the promise of missions like Europa Clipper, this icy world continues to challenge our understanding and ignite our curiosity. Its hidden ocean, potential for hydrothermal activity and dynamic surface paint a picture of a world that is far more complex and potentially more alive than its frozen exterior might suggest. Europa stands as a beacon reminding us that the conditions for life might exist in the most unexpected corners of our solar system. The quest to understand Europa is more than just an academic exercise. It's a fundamental part of our human desire to explore, to discover, and to answer the age-old question, are we alone? Each piece of data, each new image brings us closer to understanding not only Europa itself, but also the broader principles that govern the formation of habitable worlds. The universe is a vast, wondrous place, and moons like Europa offer tantalizing clues to its deepest secrets. The journey of discovery is ongoing, and Europa is undoubtedly one of its most exciting frontiers. Thanks for watching. Don't forget to subscribe to our YouTube channel for more informative videos. Comment below with your suggestions for our next video topic. Have a good day. We hope this exploration of Europa has sparked your imagination and deepened your appreciation for the incredible diversity of worlds that share our cosmic neighborhood. Until next time, keep looking up, subscribe our YouTube channel, and leave us a comment for our next video. Have a good day.